Hello students, today we will discuss vertical circular motion. There are two types of vertical circular motion. First type is that the vertical circular motion which is under gravity, which is controlled by gravity. The motion which is controlled by gravity. So the simple example that if a bob is tied to a string and the string is rotated in vertical plane, bob performs vertical circular motion. In that case, velocity changes both in magnitude and direction. In the second case, second type of vertical circular motion is that it is not controlled by gravity. The vertical circular motion which is not controlled by gravity, it is controlled by any other energy like electrical energy, mechanical energy, and the example is that giant wheel. So you might have enjoyed the motion in giant wheel. The motion is controlled by electrical, mechanical energies. In that case, here magnitude of velocity, that means speed, is constant. So this is the difference between two types. Here, if the motion is not controlled by gravity, speed remains constant, but when the motion, vertical circular motion, is controlled by the gravity, both magnitude and direction both goes on changing. In this discussion or in our scope of syllabus, we have to study vertical circular motion that is only controlled by gravity. Means the simple example we have to consider that a bob attached to a string and whirled in a vertical plane, then that motion we have to discuss and obtain various quantities related to that motion. Here, as the motion is under gravity, we have to consider one more point here that it is for the discussion is interconversion between kinetic energy and potential energy. So while deriving relations for velocities and tension, we have to consider kinetic energy and potential energy and their interconversion. According to law of conservation of energy, we will discuss further. Here, we have to show the vertical circle along which the particle revolves. So various points we show here. So the first point is uppermost point A. The second point is lowermost point B. Center of the circular path is O. Here is denoted by O. Horizontal positions are shown by points C and D. Here, simple experiment we have considered that along string, the bob is tied to a string. The string we have taken of length L, but for the sake of simplicity we denote it as R. So distance between O and one of the position is R. Now we here discuss the experience when we revolve the string. When we start the revolutions, at the bottom point, means at the point say like B, here we feel that tension is maximum or it is large, and at point A we experience that string becomes loose. Loosening of string is there. In other words, we say that tension is minimum at this point. Means at the topmost point tension is minimum because we experience loosening of string or slackening of string. So as the tension is minimum, we also say that velocity is also minimum at this point A, and at the point B velocity is maximum. This we have only stated maximum and minimum, but we have to derive the relations. So here by our experience we say that here at the bottom point velocity is maximum, at the uppermost point velocity is minimum, means we say that here velocity goes on decreasing when we go from bottom point to top point. Velocity is decreasing. Here as velocity is decreasing, the motion is retarded motion. So we show here one arrow like this, which shows that velocity is decreasing. We can also say that motion is retarded. When it is retarded, when we go from B to A. Now we show here one more point and assume that this circular motion is nearer to the ground. Here this is the ground surface. So here the B is a point which is very near to ground. At this point H is equal to 0. Means potential energy at point B is equal to 0. We take because B point is nearer to the ground. Here this is the B point. B is nearer to the ground. Now if we have to write at point A, the height of position A, here A position we show, here it is equal to this vertical displacement is R plus R, means it is equal to twice R. I have to give one more point here, that when we go from B to A, means along this half circular path, the distance covered by the particle is twice pi r upon 2, means it is pi r. But the vertical displacement is twice r. Means if we write for the potential energy, then potential energy is equal to mg into twice r, or we write it as twice mgr. At the lowermost point it is 0, at the uppermost point it is twice mgr. Here for this segment, when particle moves from B to A, potential energy is increasing. But as the motion is retarded, velocity is decreasing, means kinetic energy is decreasing. When potential energy increases, kinetic energy decreases. Here kinetic energy is utilized to increase the potential energy. Now what we can discuss in the second half of the circular motion means when particle goes from A to B, then here velocity is minimum, here velocity is maximum, means we can say that here velocity is increasing and motion is accelerated. So this concept you have to note. Here velocity is increasing, motion is accelerated, there is acceleration to the particle, but potential energy is decreasing. Potential energy at A is twice mgr, here potential energy is decreasing, means potential energy is utilized to increase the kinetic energy. As V is increasing means kinetic energy is increasing. So potential energy is utilized in increasing the kinetic energy. So there is, we say that interconversion between potential energy and kinetic energy, and this concept we have to use by considering the law of conservation of energy. We have to obtain relations for speeds. In this case, for A point the speed is denoted by VA, say like this, VA. At point C, speed is VC. At point B, it is VB, like this. So such speeds we have to obtain the relations. So first we obtain the speed at A. Now here as the string becomes loose at point A, TA is minimum, it is 0, is minimum. We have to take it as 0, and TA can be shown in the downward direction. So this is TA. Similarly here mg is acting vertically downward. Mg is always acting vertically downward for all points. So I can show it easily here. For every point weight is acting vertically downward. And for the position A, here TA is towards the center. For position C also it is like this. For all position it is directed towards the center. Now for the point A, I can write the relation like this: mg plus TA. This resultant provides the necessary centripetal force. It is mv A square upon A. Here TA minimum or 0. So this is our first equation. mg plus TA directed towards the center. The resultant gives the necessary centripetal force. This is equation number 1. Now we take for the tension as 0 is, and right hand side is mva square upon r. So va square can be equal to rg, because will get cancelled and we get va is equal to under root rg. This is our second equation. This VA can be given suffix as minimum. So VA minimum is equal to under root RG. So once we know this, we can obtain relation for VB. But for that we have to use law of conservation of energy. How can we use it? It is very simple. Here I can write at point B. Various energies we can write here at point B. potential energy at B can be equal to 0. Kinetic energy at point B is equal to half mvb square, because we have to obtain relation for it. Now there is conversion of potential energy into kinetic energy, that we have discussed already. So also we have to write potential energy at A, it is equal to twice mgr. Kinetic energy at A, it is half mva square, but it can be equal to half m into rg. By substituting for Va under root rg square, it is mr, half into mrg. So we have such four relations. We can write change in potential energy is equal to change in kinetic energy. It can be written as increase in potential energy while going up, it is equal to decrease in kinetic energy. Here increase in potential energy can be written as potential energy at A minus potential energy at B, because potential energy at A is having larger value. Similarly, decrease in kinetic energy, here kinetic energy is large. We write here half mvb square minus half mrg, it is Va. So first we take one more step here, half mva square, and substitution gives us mg twice mgr minus 0 is equal to half mvb square minus half mva square. Va is 0, Va is not 0, it is half into Va is rg, Va square is rg, Va square is rg we have taken. Now we get half mvb square is equal to twice mgr plus half mrg or half mgr. We get half mvb square is equal to 5 by 2 mgr, and vb square is equal to 5 gr. Therefore vb is equal to under root 5 gr. Simplification is simple. Here the steps are very simple. We have obtained vb is equal to under root 5 gr. This is our third equation. This vb also can be now denoted by minimum, because it takes it can take the value greater than this value, therefore it is minimum. So this here there are three equations. At point A we have obtained two equations. At point B we have obtained only one equation. Now again we try the second for B. So the second equation for point B can be related to the centripetal force. Here Pb is greater than mg. We take Pb minus mg is the resultant force, and it is providing the necessary centripetal force. This is our equation number 4. So from this equation we have to obtain the relation between tensions. Now tensions are in the equation 1 and equation 4. So we subtract equation 1 from equation 4. So we get here, we write here mg plus TA is equal to mVA square upon R. This is equation number 1. Now subtracting this, we get the equation. So I can write here VB is equal to under root 5GR. This is equation 3 is minimum value, so that we can use it. So TB minus TA, TB minus TA minus mg, so it is twice mg is equal to mVB square minus mVB square upon R minus mVB square upon R minus mVA square upon R. TB minus TA minus twice mg is equal to m upon R taken as common, and VB square minus VA square we can substitute by taking the values from equation 3 and equation 2. So VB square is 5RG, 5GR, and VA square is GR. Here m upon R into 4GR, RR will get cancelled. We get the equation TB minus TA minus twice mg. I can write it over here like this. TB minus TA minus twice mg is equal to 4 mg, and finally we get TB minus TA is equal to 6 mg. So this is our equation number 4 or 5 is equation number 4. So which relates the tensions at uppermost point and lowermost point. So this is simple discussion we have derived for VA minimum, VB minimum, and the relation between tensions. You can derive the relation for VC. You can also derive the relation for VD. For that you have to consider law of conservation of energy. In textbook exercise, one question is given that, I can read here, the question is like this: using the energy conservation, derive expression for minimum speeds at different locations. So we have derived for A and B. Now the next question is zero speed is possible at the uppermost point? The question you have to understand here. The question is like this: is zero speed is possible at A, means uppermost point. Actually, in the derivation we have shown VA is minimum but not zero, and its minimum value can be obtained by under root RG. But the question asked is zero speed is possible at A? Then the answer is yes, zero speed is possible. How can it possible? For the experiment, instead of using string, we can use rod. This rod is thin. It is a very light rod, means massless or having small weight. Such rod can be used to revolve the bob. So like a pen, there is a rod. At this end a bob is attached, and if it is rotated in the anti-clockwise direction like this or clockwise direction, the rod rotates in a vertical plane, bob performs vertical circular motion. As this rod is rigid, it does not slacken. We write here, it does not become loose, so you have to understand this point. It does not become loose because rod is rigid. We say that here zero speed is possible at the point A. So this is the discussion about vertical circular motion. Let us stop here. Thank you.